Hi. So we are given this circuit where we know some of the value because they were given to us, the VCC voltage, the resistor value. We are also given the current that flows through the drain, and we're giving these parameters here: the threshold, the width, the length, and so on. And we are asked to calculate the voltage from the gate to the source. We are being asked to calculate this voltage here. So the first thing that we will do is use the simplest equation that we know, which is the saturation equation, which states that the current is equal to 1/2 the process transconductance parameter, the width over the length, VGS minus the threshold voltage squared. And what we do is we just solve for VGS. This is quite simple. We multiply here by 2 and we divide leaving us with VGS minus VT squared. And the next thing we do is square both sides of the equation. So we could cancel here the so we could cancel here the square. I mean the elevated to the power, second power. Now we have the B G minus VT equals this. Because we are solving for BG, we pass the threshold voltage to the right side of the equation, summing, and there we go. Now all we have to do is substitute. So we have 2 times the current, 2 times the current, 6. 2 times the current over 1 milli 100 over 10 all that squared plus square root that yeah, there we go. And now it's all about using our calculator. And if I'm not incorrect, this is gonna be 2 times 6 minus 3 minus 2 100 over 10 plus 1 point. Mm, 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 mm. Yeah, so we have 2.4 volts. This is something. Let me try that again. Okay. Now that we have that calculated, all we have to do is see if this is true. How do we determine if this is true? Well, the voltage DS has to be greater than the voltage GS minus the threshold voltage for this to be true. How do we calculate the voltage BS? We could do a KBL, right here, that says that BCC minus 715 times the current well, let's put it in, minus VDS equals 0. And we just solve for B VDS. VDS is going to be equal VCC minus, it's going to be equal to 5 minus 7 times 6. This is equal to 5 minus, we have 0.71 volts. Is that less than 2 minus the threshold voltage? Is that less than this? 2.9854 minus 1. No, that's not true. Because it's not true, that means the MOSFET is not working in saturation region. So we have to do the same analysis again, but not using the triode equation. So let's do it algebraically with the triode equation, which states that the current through the drain is going to be equal to all this and we are solving for BGS. You can start dividing both sides by so we could be left with and then summing to both sides. And now we have and if we divide both sides again by the drain source voltage, we're left at the right side with this. Remember that if we have a fraction of 1/2 over 3/4, a division of fractions is the same as a multiplication, a cross multiplication of fractions. So this times this and this times this. It'll be 1 times 4 plus 2 times 3 be equal to 4 over 6. The same thing we have here. We will have ND over and here also. And we add this to the right side, the threshold, and we add it to the left side, to the right side and to the left side to leave BGS by itself. Here we could cancel this one for one of these, and finally we are left with and now it's just about substituting. The current was 6 milli. The transconduction parameter was 1 milli. The width was 100 micro over 10 micro. 0.71. That's 271 over 2 plus 1.8. If I'm not mistaken, this should be 3 volts. Now to see if to determine if this is actually the voltage at the gate and source, or the gate source voltage, this statement has to be true, that the drain source voltage, that's 0.71, is less than 3 volts minus 1.8. 0.71 is it less than 3 minus 1.8? 1.2? Yes, that is true. So we have determined that this is the gate to source voltage here.